So I'm going to talk about the molecular gastronomy and its implication, and I'm going to link it to the dysphagia, how the molecular gastronomy can help with the individuals that suffer the dysphagia. Couple words about myself. I work as a professor assistant at the Department of Food Gastronomy, Food Hygiene of the Institute of Human Nutrition Sciences. Scientifically, I'm more focused on the consumer perception, but also I deal with the culinary arts, with the sensory science, because it's all linked. I had the great opportunity to visit many universities, amongst them Wageningen in Netherlands, Chagas and TU Dublin in Ireland. And as you can see, I always wear the kitchen jacket, because this is something that shows that my approach is towards the culinary art. So I'm going to talk about the molecular gastronomy, then I will talk a little bit about the culinary precisions. What are they? And what actually we need to do with them. Then I'm going to talk about the molecular cuisine and note by note. But let's start with a simple question, and maybe you can raise your hands if you agree or not. Do you believe that molecular cuisine could begin with the humble souffle? Yes or no? Who is up to yes? All right, and you are right, because I will just show you a couple of photos. So you can see here the pioneers, the fathers, so-called fathers of molecular gastronomy. One of them was Professor Hervé Thys from France. The second was Nicolas Curti from Great Britain. And you can see the picture of mine with Professor Thys. And he started to be interested in the molecular gastronomy because he had an accident with the souffle. So he completed his PhD in chemistry, and then he invited the guests to his house, so he decided to make the souffle. And as he wasn't a chef, he started to search for the recipe, and he found one in the Elle magazine. You can see the front page of it. And the recipe said, add yolks in pairs. And he, as a scientist, started to doubt. What is the reason? Why would I, separate the yolks, the whites? So he put all things together. And would you guess, as you would guess, the result was disaster, collapse. And as a scientist, he decided to invite these guests again and do it accordingly to the recipe. And the souffle was much better. So he started to think, why does the souffle need to have the eggs added in pairs? And that was the beginning of the molecular gastronomy. The second of the scientists, Nicolas Curti, said, I think it is a sad reflection on our civilization that while we can measure the temperature in the atmosphere of Venus, we don't know what goes on inside our souffle. This is very true, and you can see some pictures of the result of the researches that he done, and he was the inventor of the reversed baked Alaska, which is the frozen Florida. So we've got the dessert that is frozen outside and hot inside. There is a science behind. He used the microwave oven, the new technique, and I'm going to show you the scientific approach to the culinary art. So as you mentioned, the molecular gastronomy evaluates the reaction in the food during the cooking and the phenomena that occurs inside while we're cooking something. But we've got two different stuff like neurogastronomy, the science that study how the brain perceived the experienced food, and we've got the gastrophysics, which is the science of diner experience. What kind of the factors affect the perception and behavior. And molecular gastronomy studies the culinary precisions. Do you know any examples of the culinary precision? Culinary precision is the common knowledge about techniques and practices used during cooking the food. Any ideas? Judith?
Oh, well, one of the things that you talked about that the students have learned all about is how you have to separate eggs, or you can't beat the egg white into a foam. So those of you who've taken 1014 know about the 3-bowl method, right? Making sure that you completely separate the eggs so there's no fat in with the egg white. So figuring out how these components of food interact and act, and what makes it foam, what makes it not foam, what makes it creamy, all those kinds of things, that would be culinary precision.
Yeah, that's the great example. Thank you for that. So this culinary precision is knowledge that can be passed through the generation. So all these tips that you could learn from your parents, grandparents, can be perceived as culinary precisions. Then they can be also found in the books, like the cookbooks. And the professor teas that you could observe gathered them almost 25,000 of them. Yeah, and this is the example of such a culinary precision. Actually, we can classify it as a kitchen myth. The precision claimed that searing the meat will allow the meat juice to be enclosed inside. It seems to be true, but it's false. It's false because the shrinkage of the meat and the juice leakage is associated with the heat treatment. The bigger heat treatment, the bigger shrinkage. So this is
coagulation.
Yep.
Shrink.
That's true. And now I'm going to talk about the molecular cuisine, which is the implication of the molecular gastronomy. So molecular cuisine is the culinary technique that has very simple definition. It's cooking with new ingredients, new methods, and new techniques. And I'm going to show you those elements shortly. And I just wanted to admit that you might see in various media various names, as molecular cuisine has many names. Techno-emotional cuisine, as using the high-tech, we're trying to arouse the emotions in consumers. New cuisine, emotional cuisine, experimental cuisine, as we use a lot of experiments. And the vanguard cuisine, and in the US they call it as culinology. Culinology, that's the American term. And you can see the vast range of those tools. Some of them were taken from the industries or laboratories, while some of them were specially designed to be used in the professional kitchens. So the examples of this first class is like the temperature circulator. Nowadays we use the sous vide bath as a modernized version, and we've got some equipment that was specially developed. Anti-griddle, we use it for the Thai ice cream.
Oh, okay.
And you can take a look right now. I will just grab a water.
Just some of the fancy equipment that they have.
This is old water bath, and this is the modernized version of it that was used before. Maybe I will just go and show you the next element, the new ingredients. The new ingredients are those who haven't been used before. So amongst them, we can find the food additives. Food additives, and I will give you the example of them. This is the maltodextrin. Am I right? How to pronounce it? All right, all right. So, have you ever heard about the maltodextrin? Have you seen these ingredients while while watching the labels.
So like if you look at the...
Okay, so what is that for?
Food, have you ever seen?
Do you have any guess? Yep. Not preservative, yeah, but maybe it can be used like that. This is this is the bulking agent. So this is used. This has amorphous structure. It absorbs the aromas and flavors. So you will observe how can we transform this peanut butter into the powder, so-called golden sand. Okay, so this is what you're gonna to taste today, but really soon. And I just wanted to show you the second category. So we've got the food additives, we've got thickeners, stabilizers, emulsifiers, and gelling agents, which are very often used in the treatment of individuals with dysphagia, yeah, and we've got ready-to-use freeze-dried fruits. Oh yeah. So today, if you will be able also to taste them again, and we'll have some surprise for you as well. So let's take a look at the examples of those food additives. Does anyone sound familiar to you? Which one? Do we have any vegans here? Do we have any vegans?
Anybody a vegan? Where if you were going to do a gelatin or something, you'd use agar instead?
Yep.
They know agar a lot from their microbiology classes because we use an agar gel.
That's right, that's right. So the agar, sodium alginate, help me, xanthan? How do you? Xanthan, yeah. Because yesterday or 2 days ago I learned that it's not the xylitol, it's xylitol. So that was very funny.
The X has a Z.
And then we've got pectin and locust gum. So just take a look. Those ingredients are extracted from the algae or obtained from the trees, the gums. So we could say that they are somehow natural, yeah, naturally sourced. And these are the surprising textures forming ingredients, and these are the examples of such a product. Just take a look at their price, quite pricey, you would say, like for $34 for the thing that contains mainly sugar inside, yeah. And if you know a little bit about the food science, and you will mix the sugar with natural aroma, you will have that for $2, I guess. So it's all about the knowledge. And we've got the second example, krumiel, which is the crystallized honey. And finally, we've got new methods of preparation. Amongst them, freeze drying, as I said, concentration, homogenization, sous vide technique, like the cooking in a low temperature under vacuum. We've got the emulsification, foaming, blast freezing, gelling, and spherification. And those two first one can be used in the treatment or in feeding patient with the dysphagia. As you probably know, dysphagia is difficulty in swallowing that affects approximately 10-20% of people over 50, rising to up to 40 in those over 60. Those individuals are malnourished because they don't find food as attractive. Because I believe you all know that those people should eat pureed foods. So there was like one girl, yeah. What's your name?
Emily.
So you can just share right now your impressions.
So at the rehab hospital, we have a lot of patients that are on like pureed or ground diets. And so I was just telling them about how we can only offer them like 4 things. Like you can have ground chicken, ground fish, mashed potatoes, like carrots, and it always looks really unappetizing on a plate because it's just mush.
Yeah, so those individuals are struggling with the malnutrition, as I say, dehydration, and poor quality of life, to be honest with you. And the food should be of good, right consistency. It shouldn't be too runny. In other way, it can go through the respiratory tract. Yeah. So the thicker consistencies are generally safer. And now I'm showing you the International Dysphagia Diet Standardization Initiative framework of the foods, and we see here the 7 degrees of thickness of foods. And for the dysphagia patients, we should go from 3 up to the 6, from moderately thick up to the soft bite size, but mostly we would stop over here. And as I said before, food looks like the puree, and nobody wants to eat it. So the molecular cuisine coming here and showing that the gelling and spherification can be used to shape the food. And you can see on the screen the results of the research that were made actually by scientists from Department of Nutrition in Boston. And those guys gave 2 versions of foods, pureed and food that was shaped using the gelling agents, so-called let's say molecular version of it, amongst the 60 patients. And they found out that the use of the molecular cuisine has improved sensory appeal, enhanced texture and safety, which is very important, and increased nutritional intake. So I'm going to explain you right now how can we do the spherification of foods. But before that, I will just show you one more chart to illustrate how this science is developing. Now you can see the 3D printing. Have you heard about that? So the 3D printing is also used to in the treatment of patients with the dysphagia. And now I'm going to talk a little bit about the spherification. For the first time it was used 2003. It is the liquid core surrounded by the edible membranes, and we can have different sizes of such as spheres. The fake caviar, so-called faux caviar from the French. We've got the molecular ravioli, which we are going to do today, and we've got even bigger, let's say, ball-size spheres. Here, probably a virgin mojito sphere, and you can take a look at the presentation that I'm displaying as a guidance for the further workshops. So you can see here the 3 bowls. One contains the foods that is full of calcium. Then we've got 1% solution of sodium alginate and the clear water. So some of you will take the ice cream scoop and will pour a spoon over the surface of sodium alginate and will leave it for 1 minute. After 1 minute, you will take the spotted spoon and you will place it into the clear water, and then the reaction, during the bathing, the reaction between the calcium and sodium alginate occurs. This is the chemically induced gelling. This is quite new. Regularly we've got the thermally induced gelling, like the gelatin or agar you said, but just take a look. When you cut it, the liquid will split out. And then we are going to serve it with the banana powder, and banana powder with some parsley. Alright, so that will be the first thing. Second thing, maybe less related to the dysphagia, but also making the food being more appeal. The cryogenic cooking, so-called cryo cooking. It uses the evaporation of the cryogenic materials, and we've got here I really regret that I didn't put here the Fahrenheit degrees, but I can tell you in the Celsius. So we've got here the liquid nitrogen. which is like minus 196 Celsius degree. So
See the smoke?
the smoke. So this is very cold. We are going to use it later on.
You'd get a freezer burn if you.
Yeah. If I would just dip my hand, I probably would get burnt. But the second one that you might know is dry ice. It's the solid carbon dioxide. In the solid form has temperature of minus 78 degrees of Celsius. And what can we do with this liquid nitrogen? We can solidify the food. So we can do the ice cream, which we are going to do. We are going to do the sorbet today, but in the special way. So I believe I will be the one who will do these ice creams for the safety reasons. But I've got the mixture of the tomatoes and strawberries. And I'm going to mix it with the basil. And I'm going to put it into the mixer. And then I will put the liquid nitrogen, and of course you will be able to taste it. This is much, would say, healthier version of the regular ice cream. The next thing that I hope might surprise you is the dragon breath. Have you ever tried it? Most of you? No?
Have you all been to creamistry or?
Okay, so for some of you it will be something new, so you can just experience it today. But as you probably know, the 196 Celsius degree on the minus is very low temperature. So when it has a contact with our palates, our mouths, it evaporates very quickly. So it creates the nitro vapors, yeah? And it has this very strange effect. And what is the reason that we are not able to burn ourselves when we have short contact with such a cold substance? It's because of Leidenfrost effect. Have you heard about that? The magnitude of the temperature differences is so big that between those two surfaces, the very thin layer of the steam is created. So, yeah. So for this reason, you can observe right now, like this water. Actually, not water, but the liquid nitrogen is wobbling, dancing on the spoon. And the same effect you can see while you dropping the water on the superheated pan. Yeah. So this is the Leidenfrost effect. And now I'm going to show you how to do this dragon breath effect. Yeah, maybe I will just...
Have you all ever had Dippin' Dots? They're made using liquid nitrogen.
What is the name of it?
Dippin' Dots. It's a ice cream, but the way they make it is they dribble the ice cream mixture into some liquid nitrogen and it forms a little ball.
Oh, that's a cool one.
Pretty fun.
So for the safety reason, we are going to do some dragon breaths, but keep in mind that you should avoid the fruits that will have this vapor. Okay? It should be, in other way you might burn yourself. So you will take it to your mouth and start to chew it, as my colleague did. Yeah, I will do the same. Yeah, so you'll be all invited to taste it today, experience this, very interesting, but keep in mind that you need to chew it very fastly, okay? In other way you can burn a little bit yourself. And the final functionality of the liquid nitrogen that I'm going to use today is to adding extraordinary fragility. So I'm going to transform this basil, freshly picked from Miss Myhand's garden, yeah, into the powder, and this powder will be added to the ice cream. So this in the same way as we did during the workshop, so you can just observe in a couple of seconds. It will be super powder, yeah, and then we are going to add it to our sorbet base. And I just wanted to give you some overview of the molecular cuisine. What is that? It uses the so-called deconstruction. So the food is puts the ingredients of the food is separated, and then we transform and modify the texture, shape of the individual ingredient, and then we transform it totally different dish that has quintessence of the initial dish. The food is served in the form of tasting menu, which means that once we receive the 400 grams of the dish, we will receive small portion, but many of them. And it's because it's not to, satisfy our starving.
It's not to satisfy hunger, it's to satisfy
the palates,
the palate, right? Fun, and I can't wait for them to see the strawberry.
Oh yeah. And then we serve it on the variously shaped plates and bowls, and you can see here that even sometimes they even hire the artist. And this food dish, the vessel, was specially designed to be served in one of the restaurants in Spain. So this is how the molecular cuisine is served. This is the example from the a restaurant called Alinea in Chicago. It's owned by the Grand Acats, a very famous restaurant. And okay, so I've got the question: what do you see on the screen? Strawberry and?
It looks like it's made it.
Yeah.
So you say that it's strawberry and tomato, yeah? But the truth is that is tomato and this is the strawberry. But shaped in a different way. So as you can guess right now, molecular cuisine is to surprise us with a new look, new shape, but also new flavor. So today you are going to learn a new combination of the foods according to the food pairing methodology. De Benzi and Blumenthal, very famous British chef, together found. So the ingredients of the same dish that have the same most abundant, dominant aromatic compounds taste better than those that do not have them. What does it mean? That some of the ingredients, they've got similar aromatics. And the same aromatics can be found in the strawberry, in the chocolate, Parmesan cheese, and the basil. So even if something doesn't match, or we believe doesn't match, well, it will taste very nice together. And today we are going to serve the banana with the parsley, and we are going to mix tomato, strawberry, and basil. And you will see that's quite new. Of course, not everyone might love it, but I believe it will be some new experience for you. And now I just wanted to tell you a little bit about the note-by-note cooking. This is totally new culinary techniques that originated in 1994. The same professor, a little bit younger, as you could observe on the photo, he wanted to develop the essential oils that would be added to the dish and enhance the flavor, but in the fact he pushed the molecular cuisine to the extremum. What does it mean? He invented the technique that involves use of the elemental compounds like glucose, fructose, and he claims that is because of the hunger coming in 2050. I don't believe this technique has potential, because I will show you what I've done in terms of these techniques, but it uses a pure compounds for the food production. So the chef is as a musician. He creates the music with simple words, simple sounds, notes, or he's like the painter using a basic color palette. Yeah. So the first dish that you can observe on the here was developed by a very famous French chef Garnier. in 2009, and since then there is a competition.
Oh, okay,
Yeah.
like a contest.
Oh yeah, thanks. Competition, and you can see here the first dish that was made. I will show you the example of others, but I just wanted to show you the all natural sherry. This is the ingredient list of the sherries and the beetroot, and this might illustrate you that even if we eat something that is naturally sourced, we need to be aware that it contains a lot of various substances, even if we are not aware. The sherry, of course, aqua 82%, but we've got the sugar. Amongst the sugar, we've got glucose, fructose, galactose, maltose, sucrose. So this is the combination of the various ingredients. I would find here like approximately 50 or 60, but in the node-by-node cuisine, you can use endless combination of the ingredients. And this technique involves using all of so-called node-by-node evocations. These are aromatics that give different flavors that we can find here. This is the isolated, I don't know, limonenon or carvol that gives specific taste. And I like the most the one that imitates the freshly cut grass. So this is the very interesting experience, and these are the examples of such a node-by-node cuisine. And what is important here from the nutritional point of view, that you can add there whatever you want to, so you can just balance the food the way you want to. I mean, I don't believe in the 30 years we'll have the node-by-node cuisine on our tables, but the professor Helvetis, he believes so. And I had the great opportunity to test myself as a chef in the School of the Culinary Art and Food Technology in Dublin, Ireland, and I created the node-by-node cooking. This is the book that was signed by the Professor Tis, but also has a lot of information about this technique. So if you are interested, you can just write it down, the name. And this is my dish, which I created: quenelle of the tomato sauce, served with the spongy cake, toast, savory meringue, and crème fraîche. Was that tasty? No, it wasn't at all. I mean, the texture was okay, but as we know, as I showed you, in the single dish, there is a lot of ingredients. Mine had maybe 20 of them. And it was very blunt in the taste. So, but
But look how pretty it is.
but yeah, but there are restaurants that specialize in such a dishes, and I am a researcher, so I involve the chefs from the Michelin-starred restaurant, and they develop node-by-node dish, and we compare it with the molecular version and traditional one. Of course, traditional one was the most, and the node-by-node was liked the least. So, what is the conclusion of my presentation? That maybe we like to experience new flavors, maybe it's something interesting, but we will always remain with our traditional foods. Thank you so much, and now it's time for the workshop. So I would like to involve some of you, whoever wants to be involved can join us, and we are going to do the chocolate chantilly. Do you know what are the ingredients of the chocolate mousse? Beside the chocolate.
What's in a mousse?
Yeah, go ahead. Cream, heavy cream, yeah, perfect. What else? Yeah, the yolks, yeah. Sometimes they add the gelatin or they add the agar. Can you believe that today we are going to create the chocolate mousse only out of the chocolate and water? So, and this is the invention of the Professor Helvetis. he found that the cream is created when you've got the certain proportions of the fat and oil and water. So he calculated how much water he needs to add to the chocolate that contains cocoa fat to give the same proportion as they are in the heavy cream. Yeah, I will ask one person to mix the spoon of the peanut butter with 2 or maybe 3, 4 spoons of the maltodextrin. Okay, and we are going to serve it with the chocolate mousse and with the freeze-dried blueberries. Yeah. And then we are going to make. This is the coconut. This is the coconut curry mango soup that I've prepared yesterday. We are going to foam how to say it, aerate it, make a foam out of it. So we are going to reheat it very soon, okay? And we are going to put it into the kitchen siphon. Then we'll add the nitrogen in the capsule. We'll close it and shake it and serve it to you with the cilantro, freshly picked from the Myhand garden. And then we are going to make the yogurt ravioli. So I've got the yogurt base prepared here. You will just put it on the surface, okay, see, with the spoon. We'll leave it for 1 minute, and afterwards we will just put it to the clear water, and then we are going to sprinkle it with lots of banana powder. And now you can, as a first, take it to the mouth, but try to not bite it, okay? Yeah, and just feel the texture. All right, so we've got time. So, in meantime, we are waiting for the sorbet. Okay, so as I said, we've got here the basil. I'm going to pour it with the liquid nitrogen, and then I'm going to mash it. Oh my goodness, that will be nice. So as I said, tomatoes, strawberry and the basil. Like this one. And now I'm going to add it. Oh yeah.
That tomato, strawberry, and basil sounded good together.
Yeah, let's see. Let's see. Guys, how do you like the sorbet? So this is it.
Yeah, that's right.
Okay, guys, so I hope you enjoyed and you are not afraid of molecular cuisine no more. And you can apply it somehow. Mm-hmm. Because as you can observe, the chocolate mousse was made only of water and chocolate. Yeah, the liquid nitrogen, as you said, it's cheap, cheap, available online. I'm going to share the recipes with Miss Myhand, and she will forward it to you.
In case you want to make them.
Yeah, thank you so much for hosting us. Thank you, Judy.